Chapter 9 Zymosis. Zymosis is a standalone code to generate the ASTROS DESVARS and SHAPE bulk data cards using the bilinear Lagrange shape function technique. The element-based design variable approach may generate a non-smooth thickness distribution on skin spot rib that can introduce manufacturing problem or stress concentration. Rather than directly selecting the thickness of each element as a design variable, the shape function approach assumes that the thickness distribution on a wing skin or along a spar rib can be superimposed by a set of shape functions. Thus, the design variables become the coefficients of the shape functions. After the optimizer solves these coefficients to achieve an optimized structure, the thickness on each element can be determined by superimposing the shape functions with their associated coefficients together. Since each shape function is a smooth function, the superimposed shape function that represents thickness distribution is also smooth. Other technical merit of the shape function approach is the number of design variables is usually much less than that of the element-based design variable approach. I'm showing here are the bilinear Lagrange shape functions, and first the user must select a group of adjacent plate elements, either C-4, C-3, or C-shear, to define a macro element, which is a quadrilateral or triangle macro elements. Then Zymosis will perform a isoperimetric mapping of the macro element from the plane of the macro element to a square shape on a reference plane. So Zymosis will project the grid point associated with the micro elements on a plane. And on this plane, you will map the macro element to a square shape. On this square shape, we can define 4 bilinear Lagrange shape functions showing here. So the thickness at the 4 corner points of the macro element are the 4 bilinear shape functions. So once you have 4 shape functions on macro element, then for the ith grid, okay, which is commonly corner point shared by its adjacent micro elements. So in this case, we have 4 micro elements, and the grid is ith grid, and we assume that the thickness on the ith grid is to be 1. And so for this macro element, we select this shape function. For this macro element, we select this shape function. For this macro element, we select this shape function. For this macro element, we select this shape function. So altogether, we have for each grid point of the corner point of the macro element, we have a Lagrange shape function, something look like this, and the thickness at the grid is 1, and on the boundary of those 4 micro elements, the shape function is 0. So give you one example, and for example, if we have a wing skin element here, and we have about 65 C-4 elements, and if we divide them into 12 micro elements, and we select 21 commonly shared grid points. So at the end, we can generate 21 DESVARS car, and each car will refer to a shape car. For example, we have grid point 94, and the thickness of the at the grid point 94 is 1, and it has shared by 4 micro element. So the Lagrange shape functions become 0 at the boundary of those 4 micro elements, and the center of the grid is 1. Okay, so so uh, the input of Zymosis consists of 2 sections. This is the case control section. This is Bogota sections. For the case control commands, it must start with the C and D, and then you can put a title there. You can put, say echo equal to sort, and or to print out the input card in the alphabetic order, or none. Disable the printout, and then you have to define a subcase. Within the subcase, you can specify a subtitle, and a label, and you must specify an outbox equal to n, and this one refer to the outbox box data cards with ID equals to n in the box data cards section, and this outbox data card will output the DESVAR S and SHAPE box data cards. And you must end this case control section by begin box. And in the box data cards, you can specify a grid, and this grid must be one of grid in the ASTROS finite element model. And you can select C quad 4, C quad 3, C shear, C bar, C rod, and con rod, and they must be an element in the ASTROS finite element model. And you specify outbox to specify an output file name on which the DESVAR S and the SHAPE box data cards are printed out. And we use a SHAPE Gen 1, which to generate bilinear Lagrange shape functions on a 2-dimensional projection plane. And this SHAPE Gen 1 card refers to a panelist 2 box card that lists a set of plate elements to define a micro element, and it refers to a set 1 card to list the corner point of the corner points of the micro element. Usually, if it's a quadrilateral micro element, you list 4 corner points of the grid ID. And SHAPE Gen 2 generates a 1-dimensional linear shape function. So also it refers to a panelist 2 card to list out the element IDs, and also it refers to 2 grid points to represent the 2 endpoints of this 1-dimensional linear shape function. Now, if we want to define a constant shape function on a set of plate elements, you can use attached. And we have applied an arrow card to allow you graphically view the grid point and plate elements of this Zymosis input, and plot shape and to display the shape functions. And panelist 2 is to list out the IDs of a micro element. And set 1 to list out the grid IDs of the corner points of macro elements. You have to end the box data card section by end data. Arrow Z card is a required card, and this card must exist. And this card's usage in the Zymosis is to make use of some routine utility routines from the Zonas arrow elasticals. Attach, you want to generate a constant shape function, and by referring to a panelist 2 cards, which lists out the plate element IDs which belong to this micro element, and you refer to a single grid. So the thickness of the single grid is the thickness of this group of plate elements. The shape gen 1, shape gen 2, and attached together link the elements with the selected grid point defined by the set 1 car. In the end, the Zymosis generate the shape cars for ASTROS. The number of shape cars is the same as the total number of unique grid point leads by the set 1 car. So you have many set 1 cars, and the unique grid ID appear in those set 1 cars will lead to a shape car. And if the okay, the next one is C bar. C bar is to select a beam element, and this beam element must be a beam element in the ASTROS final element model, and count rod also must be a count rod element in the final element model. And coordinate card define a rectangular coordinate, and we use this coordinate card. Usually we define the XY plane as the projection plane to generate the bilinear Lagrange shape function. And C-quad4 must be a C-quad4 in the ASTROS final element model. C-rod must be a rod element in the ASTROS final element model. C-shear must be a shear element in the ASTROS final element model. And C-3 must be a triangular element in the ASTROS final element model. A grid must be a grid point in the ASTROS final element model. Panelist 2 is to list out the element IDs. Okay, this panelist 2 car is referred to by the shape gen 1, shape gen 2, attached and plot pans car. The field 5 can be through, so you can say 1001 through 1010. So from 1001 and to 1010, all the IDs are listed by this panelist 2 car. Outboard is a required car, and it output the DESVAR S and SHAPE both cars generated by Zymosis, and those cars will be the input of ASTROS. So you give ID, and this ID is referred to by the case control command outboard equal to SID, and you define a starting ID for Zymosis to generate the DESVAR S car. And the layer is for composite material. If we have 4 layers and layers equals 4, V min is minimum design allowable value for the design variable. V max is the maximum value. V init is the initial thickness of the design variable. Then you define a file name here, and the DESVAR S and SHAPE both cars generated by the Zymosis will be included in this file. Shape gen 1, shape gen 2 attached together link the elements with the select grid point defined by several cars. In the end, Zymosis generate the shape and DESVAR S car for ASTROS. The number of shape cars is the same as the total number of the unique grid point listed by 7 cars, referenced by the shape gen 1, shape gen 2, and attached car. For the ID of DESVAR S and SHAPE cars is defined by if layer is greater than 1 and say layer equal to 4, then the first DESVAR S ID will be defined by the ID star, and the second one will be increment by 4. So if this one is 1001, the second one is 1005, and so on for each layer. If layer equal to S, and this is how we define the ID of the DESVAR S and SHAPE. Where grid in that index is the internal ID number of grids listed in the set 1 car. And plug arrow allows you to plug the micro elements listed in the Zymosis info file, and the plot pens allows you to look at the micro element. And so you define you refer to a pen list 2 car, list all the IDs of the play elements. And set G refers to a set 1 car, list all the grid point IDs. And the projection is if the CP refers to a contoured car, the XY plane of the contoured car is the projection plane. If project equal to 1, then you will project all the grid point onto this XY plane. If CP is 0, and the XY plane of the global coordinate will be used if project is not 0. Plot shape allows you to look at the shape functions generated by Zymosis. Again, it refers to a shape class. And set 1 is to list a set of grid point IDs, and usually the set 1 is to list the IDs of the corner points of a micro element. And shape gen 1 is to generate bilinear Lagrange shape functions on a 2-dimensional projection plane. Again, it refers to a contoured car, and the XY plane of the contoured car is the projection plane. And then you list out and set K refers to a pen list 2 car to list out the IDs of a group of elements as one micro element. Set G refers to a set 1 car that lists the grid point IDs as the corner point of the micro element. So so if the CP is 0, then the XY plane of the global coordinate will be used as the projection plane. And so once we project the corner point and those panels on a projection plane, and we can map this micro element to a rectangular shape, and we define 4 sets of Lagrange shape functions on this micro element. And shape gen 2 is to generate a 1-dimensional linear functions. Again, it refers to a pen list 2 car that lists the element IDs. It refers to a set 1 car. Usually we list out 2 grid point IDs of this micro element. Again, and this one is referred to a contoured car. The y-axis defines the projection axis. So shape gen 2 needs to project the grid point onto a projection axis. Okay, and along this projection axis, we can define 2 1-dimensional linear shape functions. And you must specify n data to end this bulk data section.